Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome once again to all of you to the physics classes. Dear students, we were talking about motion in a plane, and after that in that one of the example we have studied, that is motion in a plane, that is nothing but object, that is nothing but projectile motion we have studied. That is the example for motion in a plane. Now we will calculate the direction and acceleration. How we will calculate? So in a plane, what we will do, say for example velocity is in this way, means we can divide it in this way, isn't it? One is x component, one is y component, like that we can divide. Okay. Now how was that motion, that projectile motion? That projectile motion was nothing but in this way, in the x y plane, that object is moving in this way. Now what happens, this is the highest point, this is the highest point. Now this is the velocity you have written, tangent. Now what is the initial velocity? You can write down initial velocity, we can divide, that is v naught x, v naught y, because v naught along x direction, v naught along y direction. So v naught x is nothing but v naught cos theta, all those things we have derived. Now this is the direction I know. Now if I want the direction here at this point, I have to draw the tangent and I have to divide it in x and y direction. If I have to know the direction here, this is the velocity, I have to divide into direction. Now what is the velocity at highest point? See, if it is going upward means and going x axis means this is having both two velocities. X velocity is also there, y velocity also there. It is moving in x axis also, it is moving in y axis also. But what about at this point? Whether it is moving again more and more? No, it reaches maximum, going up, going up, going up, going up and up. Finally it reaches to the maximum point. After this maximum point, it won't going up, no? So Vy is equal to 0. Then what is this remaining velocity? What is the velocity at highest point is? What is the velocity at the highest point? 0. Generally, that thought came into your mind. Yes, when you throw an object to the upward, it goes so up, and at the highest point velocity becomes 0. See, if suppose 0, okay, what is the velocity of the object which is at rest? Velocity of the object which is at rest is 0. If suppose velocity is 0, the thrown object must be there itself, it should not come back, no? So velocity is not 0, but there are two velocities are there, okay? One is Vx velocity, another one is Vy velocity. At the highest point, Vy becomes 0, but Vx will be same as that of the initial velocity, whatever you have given, that is V naught cos theta, that is V naught cos theta, or V naught cos theta it would be, no, that is what, okay? Or V naught, highest velocity will be always whatever the velocity at the highest point is, Vy is going to become 0, Vy is going to become 0, and Vx is nothing but cos 0 it becomes, no? So Vx is nothing but cos 0 is nothing but 1, that is V naught it becomes here at the highest point. Again it comes back, you will draw a tangent, okay? This is the x velocity, this is the y velocity in the negative way, no? X velocity, y velocity, like that. Perpendicular you have to draw in this. Now at the highest point, what is the direction of velocity? At the highest point, velocity Vy velocity is 0, Vx velocity is V naught, and the velocity direction in the x axis. What is the direction of acceleration? We always say that Ax is 0, means there is no acceleration along x direction, and Vy is equal to minus g. and this minus g is always downward, always downward, always downward. So here also minus g is in this way. So they will ask what is the angle of acceleration and velocity at the highest point of the projectile motion, that is 90 degree, that is 90 degree. Here may not be 90 degree, no, here may not be 90 degree, like this it is. Always g, v velocity was this way, no. So v velocity was this way, 90 degree, always g will be in always like this. Okay, there is no ax, no, only ay, no, like that. So always acceleration is downward and it is perpendicular. So in this class, now we are going to talk about one more example for motion in a plane, that is nothing but uniform circular motion. Uniform circular motion. Uniform circular motion. What do you mean by uniform circular motion? What do you mean by uniform circular motion? Object moving in a circular path. Object moving in a circular path, okay, or in a circle with a constant speed, that is nothing but uniform circular motion. Object moving in a circular path with a constant speed. So in a circle, this is the center, that object is moving, no? Say for example, somewhere the object is here. Object moving in a circle with the constant speed. See, speed is different, velocity is different. Speed is different, velocity is different. What do you mean by velocity? Velocity is a vector which has got some direction, but speed is nothing but the magnitude of velocity. Magnitude means what? That number is nothing but velocity. The number of that speed is nothing but number of that velocity is nothing but speed. Number of that velocity means what? See, I will write down velocity 23 I cap meter per second. 23 meter per second along x direction. The meaning is, now if I write down speed is only 23 meter per second. You are not supposed to write down the direction. Simple. Okay, just number. Okay, like that. Now in a circular motion we are going to study. In a circular motion, that is nothing but uniform circular motion. So how you are going to find out? So position vector you are going to write down. Now at the first, the position of this object is here, r vector. So in the next, after some time, position will be here, that is r dash vector. This is O, this is P, this is Q. From where to where that object is moving? From P to Q that object is moving. This becomes delta R, no? See, according to triangle law of vector addition, how we can write down? R vector plus delta R, which is equal to R dash, no? Added to tail. Actually, position means what? Displacement with marks. This is the displacement, no? From P to Q is the displacement. That is nothing but R2 minus R1 it should be, no? And that is what we are going to get, no? Final minus initial. That is R dash vector minus R vector you are going to get, no? Same way. So the displacement will be in this direction. This is delta R. But I'll erase this. You can write down after this diagram. But what R dash properly write down? R dash vector. Okay, like that. Now R dash is a vector again. Okay. So, but this is nothing but also radius, isn't it? It's nothing but a radius of that circular path. Now I am going to write down. Now I am going to write down in such a way that what is the velocity? It is moving in a circular path with a constant speed. We are going to say the meaning is the speed is constant. Okay, means that number is constant. It is moving with means 23 meter per second, 23 meter per second, like that. Then what is the velocity? Velocity I have to draw by drawing a tangent. For our position vector, we are going to write down velocity v. So here also I have to draw the tangent, that is nothing but v dash I am going to write down. It is a vector, it is a vector. Is velocity in this way, this velocity in this way. Always these are perpendicular, no? Tangent and this radius. Tangent and this radius are perpendicular to each other. Now what I want? What do you mean by acceleration? See, object is moving with constant speed. Object is moving with constant velocity. Constant speed, not constant velocity. Whether it is having acceleration, that is my question. Object is moving with constant speed, whether it is having an acceleration. Now you say that no, or you say that yes. Okay. So those who are saying yes or those who are saying no, now listen it is having acceleration. Now constant speed means you may think that there is no velocity, velocity direction is there, no, velocity must be constant. No, magnitude of velocity is constant, but direction changes, no. See, this direction is not same as, if I write down in this way, this is the first direction, this is the second direction, this is third direction. Velocity length is same, 23 meter per second, 23 meter per second, 23 meter per second. Why 23 only? Simple example I have given. It may be 20 or it may be any your favorite number, okay. But whatever I write down for this circle, tangent, the direction is going to change each and every time, no. See, for the smallest point itself, no. See, if I am going to write down here, the tangent will be in this way, but the same way I will erase this one more point here, the tangent is different. Each and every point the direction is going to change, means that velocity is going to change, means that velocity is going to change. If the velocity is going to change means there is a acceleration. But see, if a vector has to change means it need not be only it has to change its direction, okay, it has to change its magnitude, okay. If it is only changes its direction, vector is changes. If it only changes its magnitude, vector is changes, okay, or both magnitude and direction is changes means vector is changes. So here velocity is, magnitude is constant. With a constant speed it is moving, 23 meter per second, 23 meter per second, 23 meter per second, like that it is moving, or 20 meter per second, 20 meter per second, 20 meter per second only it is moving. But each and every point it changes the direction, no? Because vector direction changes, no? So there is a change in velocity. If there is a change in velocity, there is a acceleration. So what is our aim is to find out? Our aim is to find out the acceleration. Now how I can find out the acceleration? I can find out the acceleration is nothing but acceleration which is equal to delta V, no? Delta V by delta T. Okay. So how to find out that delta V? So delta V means change in velocity, okay. Delta means is the notation, okay. So V2 minus V1, no. So V2 minus V1 means V dash minus V. How I can write down? How I can write down, okay. So how to find out that change in velocity? I have to write down this vector, no. I have to write down this vector in here. So this becomes V. I should not change the direction of this vector, but I can place it anywhere. So I will write down here using parallelogram law of vector addition. No, see, the adjacent vector you will write down, some parallel vector you will write down, the diagonal gives the resultant that you have studied, no? In the same way, what is going to happen? This is V dash. V dash is a vector. Now this angle is theta or delta theta. Why delta theta? Delta theta is small, okay. So don't worry about why we are writing delta. Okay. So delta is nothing but, see, delta is nothing but a small angle. Just to represent we are writing. See, both are perpendicular, no, like this. This is R, this is V. 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 So R, this is V. R, this is V. See, both are, since it is perpendicular in this way, the angle between delta theta, the change in angle between R and R dash will be same with respect to this, that is delta theta. If you are not going to see means this is delta theta, okay. Okay, that is small I have written, that's why I am telling. Okay, now V to V dash is changed, that becomes delta V, that becomes delta V, isn't it? Now from this you can write down V plus delta V is equal to V dash, and delta V is nothing but V dash minus V, and that is what we needed. Delta V is nothing but V2 minus V1. V2 is nothing but here V2, second velocity, the first velocity. See, the acceleration is there because velocity, though magnitude of velocity remains same, the direction of velocity changes, there is acceleration if an object is moving with uniform motion, uniform circular motion. Though it is moving in a constant speed in a circular motion, it is having a acceleration. And what is that direction of acceleration? The direction of acceleration is in the direction of delta V, and the delta V is always towards the center. The delta V is always towards the center. Now you draw a diagram in this way. First I have wrote here, isn't it? Now I will decrease it in this way. V and V dash. Okay. This is the center. It was like this. This is R dash and R. If you write down like this also, see, the delta will be here. So wherever you write down, this will be, no, that this will be. So wherever you write, this is V and V. Always delta V is towards the center. Always delta V is towards the center. So what is the meaning of that? So direction of acceleration is always towards the center. Direction of acceleration is always towards the center. Why we are drawing all this graph and we are talking about like this? Because, why? Because writing the diagram will give us the direction. Writing the diagram will give us the direction. Now what we understood? Yes, uniform circular motion means object moving in a circular path with constant speed. Object moving in a circular path with constant speed. Okay. Though it is moving in a constant speed, there is a change in velocity. Why there is a change in velocity? Because the direction of velocity is going to change at each and every time. Direction of velocity is going to change at each and every time. If the direction of velocity changes each and every time, there must be acceleration. Because velocity is changing, no, there must be acceleration. Then what is the direction of acceleration? Acceleration direction is always towards the center, towards the center. So this is called centripetal acceleration. This is called centripetal acceleration. Centripetal acceleration means, see, tie a stone from a thread and rotate it like this. Always that acceleration is towards the center of you. The same thing we are writing here. No, taking a stone, tying to the thread and rotating. Acceleration is always towards the center. Acceleration is always towards the center of you. Now that is called centripetal acceleration. We understood that direction of centripetal acceleration is towards the center. This drawing you have to do, this diagram you have to do. Now what is the magnitude of centripetal acceleration? Direction is towards the center. What is the magnitude of centripetal acceleration? That we have to understand and we have to write down. Okay. So consider an object which is moving in a circular path. You would write down. Consider an object which is moving in a circular path with radius capital R. Okay. Moving with a constant speed as shown in the figure. Moving with a constant speed as shown in the figure, isn't it? So how I can find out the acceleration? What is the expression for acceleration? Before only we have written, no, acceleration is nothing but we have, that is nothing but acceleration is nothing but we have, acceleration is, before that you write moving is the constant. The direction of the acceleration is always towards the center. The direction of acceleration is always towards the center. This acceleration is called as centripetal acceleration. This acceleration is called as centripetal acceleration, that you have to write down. Why it is called centripetal acceleration? Because it is in the direction of center, okay. So you wrote to consider an object which is moving in a circular path with a constant speed as shown in the figure, which is having acceleration, okay, which is the direction of acceleration is towards the center of the circular path. The radius of the circular path is r, okay, and the direction is towards the center. So to find the magnitude of the centripetal acceleration, we have average acceleration. See, average bar acceleration is equal to delta V by delta t. No, delta V by delta t, average value delta V by delta t. Now what we are going to do? Each and every time the velocity changes. So average acceleration is not matters here. You have to find out the instantaneous acceleration. You have to find out the instantaneous acceleration by taking, okay, we have to find out the instantaneous acceleration. So to find the magnitude of the instantaneous acceleration, hence instantaneous acceleration A vector, it is A bar vector, A vector, which is equal to limit of delta t tends to 0 delta V by delta t, no, delta V vector. But acceleration direction we always know, right? Direction already know. So we have to find out only magnitude. So to find the magnitude can be written, only magnitude is we want, magnitude is like this, we are going to write down A vector which is equal to limit of average acceleration, magnitude, again vector magnitude, only number you are going to write down, okay. I'll erase this, okay, I'll erase this, that last step you have to write down. Since we need the diagram, I'll erase this, okay. Say for example, this is OPQ and this is ABC. Similar triangles, no? Those are similar triangles, okay. Now we can write down from triangle OPQ and triangle ABC. Both are similar. That imply similar triangle means base divided by any of the length is equal to base divided by any of the length of the another triangle, okay. So the ratio of the base and one length, so that what we are writing, length means no magnitude, no, only, sorry, length means no direction, only magnitude. One base and one side we are going to write down V, There is no vector, that's why magnitude only we are going to write down. Vector, after that mod you are going to write down, which is equal to, next for this how you can write down, okay, equal to you have to write down, after that base, no, delta r was a vector, r, okay, r, mod divided by corresponding side is r. I'll erase this. So continuously write along with me. Now delta V by, okay, delta V is a magnitude V1 is equal to, length of R means how much? Capital R, no? So what you are going to write down? V vector goes here. So delta R, okay, delta R is this much divided by capital R into, this will go here, we are going to write down V. Because magnitude of V vector you can write, see, magnitude of A vector you have written as A, magnitude B vector you have written as B. Similarly, magnitude of V vector we are going to write down as V. Okay. This was equation 2. Then which was equation 1? Equation 1 you write down that we have written earlier, that I have erased, that is nothing but A, which is equal to limit of delta t tends to 0, delta V vector by delta t. This was the first equation. Now equation 2 in equation 1. 2 in equation 1. What are you going to get? A. A vector means how we can write down? The magnitude, just A you are going to write down. Okay, which is equal to limit of delta t tends to 0. Limit of delta t tends to 0 into, now delta V means what? Delta V means this much. Okay, delta R vector magnitude into V divided by R into delta T is there, no? Delta T. See, V and R is constant, you can take it out. So acceleration which is equal to V and R. There is no limit for V and R. Magnitude is same, no, magnitude is same, no, magnitude, V means magnitude, R means that total, and that is not going to change, no. So limit of delta t tends to 0, delta R magnitude by delta t. This is not mod, okay, this is a bracket. Now what do you mean by delta R by delta t? Search your books and find out. Delta R by delta t means what? Think. Delta R by delta t, I'll erase this. Delta R by delta t, limit of delta R by delta t is nothing but, it is nothing but instantaneous velocity, limit of, as the limit tends to, delta t tends to 0 of average velocity. So you can write down average instantaneous acceleration is V by R into V. Delta R by delta t is nothing but V. So you are going to get acceleration which is equal to V square by R, and this is called AC, that is nothing but centripetal acceleration. For 5 marks this derivation may come, it is very important. Okay. This is called centripetal acceleration. What do you mean by centripetal acceleration? It is always center seeking. This always center seeking. Okay, means towards the center. The expression for centripetal acceleration is AC is equal to V square by R. V square by R. So centripetal acceleration is nothing but the acceleration, the direction whose direction is always towards the center. What do you mean by centripetal acceleration? They are going to ask. So you can write down acceleration acting on the object undergoing the uniform circular motion is called centripetal acceleration. Acceleration acting on the object undergoing uniform circular motion is called centripetal acceleration, and which is directed always towards the center. So this is what centripetal, this is what magnitude of centripetal acceleration. This is nothing but magnitude of centripetal acceleration. So diagram you have to write down properly. See, always writing this diagram, no, along with that only you have to write down, no. That only you have to write down. Here and there you should not write down. Okay, exactly you have to write down. Okay, this is very, very important, like this. This is what centripetal acceleration is. So what is the SI unit of acceleration? Meter per second square. What is the SI unit of centripetal acceleration? That is also acceleration. The SI unit is meter per second square. The SI unit is meter per second square. So always it is going to change, no, always, in each and every time it is going to change, no, that's why it is centripetal acceleration, that's why it is centripetal acceleration. Okay, so this is what about I can say centripetal acceleration. Okay, so go through this once again study exactly. Okay, for today's this much is sufficient. Thank you very much.
Don't forget to like our video and subscribe our YouTube channel for all the updates.